So compound interest, what is compound interest? Well, if we take a really simple example, so I'm going to work through this example, but I just want to first kind of go through just a kind of general idea so you have an idea of what compound interest is. So if we take, for example, so let's get an idea of just general interest. So imagine if I said to you, okay, here's €100, so you have €100, and I tell you to put it into the bank, and in the bank you're going to get an interest rate of 6% per year. So after a year, for example, you're going to get 6% of 100. So you're going to, after a year, you're going to have about €6. So you're going to have €6 interest. Okay, so that's after 1 year. So your new balance is going to be €106. Okay, so that's after 1 year interest added on. Now, when we're dealing with, so when we're looking at like compound interest, so the amount that you start off with is this thing that's called the principal. So, and we give it the letter P. So when we look at this compound interest formula, you see this P here, that stands for principal. The principal is the amount that you start off with, or the amount of money that you put into the bank or wherever to begin with. We have an interest rate, so that's your interest rate, which is I. Okay, so the interest rate in this case is 6%. And then you have time, okay, so the number of years. In this case, so after 1 year, we make 6% interest, so time is in years, for example. So what we can say is that, let's say after 1 year, so let's say after 1 year, we're going to have 6% interest accrued. Okay, so that's of €6. So our savings or our balance is going to increase to €106. So then what happens is, let's say if we keep it in for another year, well, now it's going to be 6% of €106. So we're going to get slightly more money than €6, let's say the second year around. And then starting into the third year, we're going to have a new balance, okay, or a new principal with added on. And what happens is over time, for example, if this money is just left in there and you have interest accruing on it every year, for example, what's going to happen is you're going to get what's known as compound interest. So we need to be able to, so this formula makes it easy for us to kind of figure out and calculate, well, how much interest would we have, like what would the balance be after, let's say, 5 years. So instead of having to go through each time, so for example, to figure out what we get in the first year, I have to calculate 6% of 100, €6, then add it on. Then for the second year, I'd have to calculate 6% of 106 and figure out what it is and add it on. And then I'd have to keep doing this every single year. Now, instead of doing that, what we can do is we can just use this formula here. So this formula is used to calculate this thing that we call compound interest. So how does the formula work? So again, all we have to do is we take the values from the question and we plug them into the formula and then we work it. So if we have a look at this, so use the compound interest formula, which is this guy here, to find the compound interest which accrues on €2,800 invested for 3 years at 7.5% per annum. So we have everything that we need here. Okay, so we have the principal, which is this amount here, that's the amount that we put in. We have the time, which is 3 years, and we have the interest rate, which is 7.5. Okay, so this is P for the principal, this is time, and then this here is I for the interest rate. So what we do then is we can plug them into this formula. So F is the final amount, or what you end up with, let's say in this case, after 3 years. So the final amount F is going to be equal to the principal, which is €2,800. So 2,800 multiplied by 1. So 1 plus, and it asks for the interest here. Okay, now what's really important with this is you have to put the interest in decimal form. Okay, so decimal. so decimal form. So if we take, so for example, the question here, it gives us the interest rate in percentage form. So 7.5%, we have to convert that to a decimal. So we take 7.5 and we divide it by 100 to turn it into a decimal. So if we do that, it's going to be equal to 7.5, so 7.5 divided by 100, and that's equal to 3 over 4, and then just to change it from on your calculator, 0.075. So it is 0.075. So this is the interest rate in decimal form. So it gives it in percentage, we just divide it by 100, and that turns it into a decimal like this. So always when you're working with this formula, the interest rate has to be in decimal form. You have to put it in decimal form. So if they give it to you in percentage, you have to change it to a decimal. So it's 1 plus the interest rate, which in decimal form is 0.075. So 0.075. Okay, and so it's this multiplied by 1 plus the interest rate, and then that's all raised to the power. So see the way you have it's raised to the power of time, which in this case is 3 years. So this is all raised to the power of 3, like so. So that's kind of the first part. Read the question, identify the principal, the time, and the interest, and then using this formula here, you plug the values into the formula. Now what you have to do is you have to use BIMDAS. Okay, so what you learned in first year, your order of operation, you have to work this out. So the first thing you have to do is you have to do what's inside the brackets first. So this will become, so it'll be 2,800. So 2,800 multiplied by 1 plus 0.075, that would be 1.075. And that's all raised to the power of 3. Okay, so the next thing then that you have to do is this indice here, or this power. So it's 1.075 to the power of 3. So you can just use your calculator to do that. So you take your calculator like so. Let's just clear this. So you put it in, so 1.075, so 1.075, and you can use this button here, so X, and it has a box above it. So that's to raise like whatever number you want to whatever power you want. So we're going to raise it to the power of 3. Okay, so to the power of 3, so it looks something like that, and then we multiply that out. So that's equal to 1.24. So we'll stay with, let's say, 1.24. Okay, so it's going to be 1.24 multiplied by 2,800, and now we have to multiply these by each other. So this multiplied by this, so it's going to be this amount multiplied by this amount here, 2,800, which is equal to 3478.43. So 3478.43. So F is equal to euros 3478.43, and we can just round it. We can just round it to 3,478 euro. So this basically tells us like how much. So if we put in, let's say 2,000, so we start off with 2,800. After 3 years at an interest rate of 7.5%, the compound interest, let's say, so it'll basically, this amount will grow to this value here. Now the question specifically asks, use the compound interest formula to find the compound interest. So you're actually going to ask for the compound interest. So this like amount here, it includes the 2,800 that you put in, plus the interest that accrued on it, that brought it up to 34478. So in order to get the interest, you have to take this final amount and subtract the original amount that you put in, so 2,800. So it's going to be So 3478 minus 2,800. So you have to subtract these from each other to find out like just how much interest you've actually, how much interest accrued, if you like, since you put the value in. So if we take, let's just clear this here. So 3478. So 3478 minus 2800, and that's equal to 678 euro. So 678 euro. 678. So 678 is the interest that actually accrued since from when the original amount was put in. So we put in 2,800 at an interest rate of 7.5% for 3 years. After 3 years, it grew to that amount, and the interest. So if you take out what you put in from the amount, from what it ended up as, you end up with the interest rate, which is 678 euro. So that's really that's the compound interest formula. That's basically how you use it. There's nothing like majorly kind of complicated about it. So this is your formula. The really important thing is that when you're putting in the interest rate, normally they'll give you the interest rate as a percentage in the question, but you have to convert the percentage to a decimal. Now this is stuff you would have done in first year, changing decimals to fractions and changing fractions to percentages and to decimals. So in order to change this to a decimal, you just take the percentage amount and divide it by 100, and that will change it into decimal form, and that's what you put in here into your formula. So P is the principal. In this case, that's the amount that was put in. The interest rate is 7.5. As a decimal, it's 0.075. And T here, this T, so this is all raised to the power of T. So T is the time, and in this case, it's 3 years. So that's the compound interest formula, and a kind of typical question that would be asked in order for you to use or work with this compound interest formula.